Hey everyone, welcome to Unit 3, Parallel and Perpendicular Lines. The first lesson is on transversals and the basics of how we create these angles. The learning target for today is I can identify and explain angle relationships that occur with transversals. So before we dig into the new stuff, we have to refresh some vocabulary that we know. We've talked about before what parallel lines are and what perpendicular lines are. Parallel lines are lines that never intersect. And the special way that we note parallel lines, remember, is with those arrows. That's how we note that those two lines are parallel. That means they go on forever in both directions, never intersect. And perpendicular lines are lines that intersect at a right angle, and we note that with that little box. The beginning of our new vocabulary is this thing called a transversal. A transversal is a line that cuts through at least two other lines. So in this, at least in the beginning of this unit, we are going to be labeling our lines with a single letter because we will have a bunch of lines. So I could say, for example, lines A and B. We have those two lines. And our transversal is M. Because when we do that line, that's what creates all those angles, 1, 2, 3, 4, 5, 6, 7, 8. If we didn't have that transversal M, we wouldn't have any angles. If we had just A and B, but if we didn't have this transversal M, let's see if I can just delete it. See, we don't have any angles anymore. We would just have two lines that may intersect at some point. Because those nicknames there are nothing, there aren't any angles. So the transversal, when we draw that thing, that's what really gives us the angles that we can work with and the relationships that we want to try to find. So some things we already know about transversals, some angle relationships, are things like vertical angles. Well, if we have these two lines that are cut by this transversal, we'll form those 8 different angles. Well, we know we've got some vertical angles here. Vertical angles share a vertex, but are on opposite sides of the two intersecting lines. So for example, angles 1 and 4 are vertical angles. Another pair would be angles 2 and 3. Another would be down here, so it could be angle 5 and angle 8. And then another one would be angle 6 and angle 7. So those are different pairs of vertical angles. And remember, one thing about vertical angles is vertical angles are congruent. So angles 1 and 4 are congruent to each other. Angles 2 and 3 are congruent to each other. 5 and 8 are congruent to each other. 6 and 7 are congruent to each other. The other angle relationship that we know previously, I want my eraser. Why did that not erase? Oh. There we go. So the other angle relationship we know previously are linear pairs. And I don't have the ability to list all the linear pairs, but I could go some examples. So just looking down here at this part, linear pairs are both supplementary and adjacent. So angle 5 and angle 6, angle 6 and angle 7. Nope, I'm sorry, not 6 and 7, it's 6 and 8. Got a little overzealous there. 6 and 8, angle 8 and angle 7, comma, angle 7 and angle 5. And that's just down here. If you're looking at the top part, those angles 1, 2, 3, and 4, those have linear pair relationships as well. And remember, linear pairs are supplementary, so they add to 180 degrees. Those are relationships we already know. Some new ones, when we have two lines cut by a transversal, we have other ways that we can compare angles. So the first thing we're going to do is just start looking at some of these relationships and naming them. I want us to think about interior angles. So interior means they're going to be inside or in between the two lines. So interior angles are angles on the inside of the lines cut by the transversal. Here, our interior angles would be angles 3, 4, 5, and 6. Would be these angles here because they are inside the two lines that are cut by the transversal. And then the exterior angles are the angles on the outside of the lines cut by the transversal. So that is both those angles, angle 1 and 2, and angles 7 and 8. Interior are inside the lines that are cut by the transversal. Exterior are outside the lines cut by the transversal. So once we have those relationships, or those vocabulary ideas, we can start getting more specific with how some angles are related. So we can look a little bit more specifically for things called alternate or alternative. I like alternate interior angles. So not only are they interior, but they are on the opposite sides of the transversal. So alternate means opposite. So they're on the opposite sides of the transversal. And they are interior, so they're both inside those two other lines. So alternate means on opposite side of the transversal. So if I were to pick angle 3, the alternate would be the one on the other side of the transversal, so it would be angle 6. So angle 3 and angle 6 are alternate interior angles. Another set of alternate interior angles is angle 4 and angle 5. If we've got such things as alternate interior angles, we can also have alternate exterior angles too. Let's scooch down just a little bit. There we go. Angles 4 and 5. So we could also do alternate exterior angles. They're still on the opposite side of the transversal, but they're outside the lines that it cuts through. So that would be like angle 1 and angle 8. Or angle 2 and angle 7. So we're just looking at angle pairs, specific pairs of angles and how they could be related. We have alternate interior, alternate exterior. Next, we've got some other ones. We looked at if our two angles were on opposite sides of the transversal, if they were alternate, but they could also be same side. So same side interior angles are going to be on the same side of this transversal M. And they are both on the interior of the two other angles. So that could be like this, angle 3 and 5. Or angle 4 and angle 6. So if we could be talking same side interior angles, we can also do same side exterior angles. Same side exterior angles are on the same side of the transversal and on the outside of the lines it cuts through. So here it would be like angle 1 and angle 7. Or angle 2 and angle 8. Angle 2 and angle 8. So if we're thinking, what's the point of having all these angle relationships? We will get to that a little bit later in the lesson on specific and special relationships that show up when we have same side interior angles and there's a special relationship there, or alternate interior angles if they're congruent, that type of thing. We'll get to that a little bit later. But right now, I want to focus on all the possible types of relationships that we have with these angles. We have just a few more. So the last ones we have are things that are called corresponding angles. Corresponding angles are angle pairs on the same side of the transversal and the same position on the lines cut by it. The way that I think about it is by just doing a big F relationship. So if I'm thinking about this angle 8, the corresponding angle to that is when I just slide everything up so it's in the same spot. The same position, but just slid up that transversal. So angle 8 and angle 4. Hey, wait a minute, what does that look like? That looks like an F. So angle 8 and angle 4 are corresponding angles. We could also look at, if we wanted to, angle 6. And that would be corresponding, if we slide it that way, to angle 2. Those two angles. And yeah, that doesn't look like an F unless you completely flip everything around. But angle 6 and angle 2 are also corresponding angles. So what I will want you to do is be able to, if you are given, say, two lines, line here, lines A and B, cut by this transversal C, and I tell you two angles, I want you to be able to tell me the relationship between them, which one of the angle relationships it is. So the first ones we have are angles 3 and 6. Well, angle 3 is right here, and angle 6 is right there. So they're on the same side of that transversal C, same side. And they are both inside the two lines that the transversal is cutting. So that is same side interior angles. That's the relationship between angles 3 and 6. So how about this next one? Angles 5 and 1. Well, let's erase a little bit of this first. Angle 5 is right here. Angle 1 is right here. So let's see, they're on the same side of the transversal. Angle 5 is inside of the other two lines, but one is outside. So that means that if we're looking at this angle and that angle, well, that starts to form this, which if we turn our heads the right way, it looks like a letter F. So it's got that relationship, and that relationship is corresponding angles. And that's the main idea for today, is to be able to understand those different angle relationships. I want you to continue on. Later in the lesson, we will figure out specific angle measures, those relationships, if we have two parallel lines cut by a transversal. So be prepared for that.